In this video, we'll take up the homework sheet on properties of exponential functions. For the first question, they wanted me to study the functions y equals 2 times 3 to the power of x and y equals half times 1/3 to the power of x. So first they gave me a graph. You can really just graph 3 to the power of x and then apply a vertical stretch by a factor of 2. You can graph 1/3 to the power of x and then apply a vertical compression by a factor of 2. You can, and then once you have a graph, you can check on Desmos. Domain and range. Once you have the graph, you should be able to study it. The x and y-intercepts. Well, the y-intercepts you can find by letting x equal 0. As for the x-intercepts, the graph is telling you that there are no x-intercepts. Right? The equation of asymptote. There's only a horizontal asymptote. Oh, I forgot intervals of increase and decrease. Well, from the graph, you can tell that 2 times 3 to the power of x is increasing and half times 1/3 to the power of x is decreasing. Okay, so for question 2, I have the general equation y equals a times b to the power of x. Now it's a, I put a because I can see that the y-intercept is not equal to 1, which means that I have to solve for the value of a, because I must have applied some vertical stretch or vertical compression, because b to the x, y equals b to the x always has a y-intercept of 1. Now since it's not 1, then yeah, I gotta solve for a. Anyways, I solve for a, and then I can solve for b by subbing in another point. There's your equation. For question 3, it's a pretty silly question, but graphing half to the x and 1 over 2x. Those are very different functions. So I showed you two graphs. 1 over 2x you can graph in the you learned this from the transformations unit. It's basically a transformation applied to 1 over x. It's a horizontal, let's see, 2x, there's a horizontal compression by a factor of 2. So I stated the similarities. So they both have no x-intercepts. They both have a horizontal asymptote of y equals 0. They both decrease over its domain. As for differences, they have different domains, different ranges. And then y equals 1 over 2x has a vertical asymptote. And they have different y-intercepts. Okay? Well, in fact, 1 over 2x doesn't even have, y equals 1 over 2x doesn't even have a y-intercept. For 4, we have a ball bouncing, and it's modeled basically using an exponential decay function. You can solve for the height of the ball after any number of bounces. Just let x equal that value. And 5 represents the height of the initial height of the ball, whereas 0.65, that's actually very interesting. We're going to talk about that. But basically it means you retain 65% of the height after each bounce. So you're losing 35% of the height. If the material of the ball is such that its bounce is greater, the rebound in each bounce, then 0.65, it'll be greater than 0.65 because you're retaining more of the height that you had from before after each bounce. So I don't know, you can change like 0.65 to like 0.8. You retain 80% of the previous height after each bounce. But anyways, that's it for this homework sheet. So hopefully there weren't too many issues.